This video will talk through systems of equations. And a systems of equations, problems that involve systems of equations, you would be analyzing, graphing, algebraically analyzing a group of equations within the same problem. So you would be analyzing two or more equations, you would graph them on the same grid, or you would algebraically solve two or three equations simultaneously, looking for one xy ordered pair that would satisfy all of the equations within that system. The most common outcome for a system of equations is the one solution outcome. Sometimes it's referred to as independent or consistent. When you graph a system of equations with one solution, you have one intersection point. Algebraically, the outcome would lead you to one x value and one y value that would bring you together with an ordered pair that would make all of the equations within that system true at the same time. The no solution system, sometimes referred to as inconsistent, when you graph a no solution system, you end up with a pair of parallel lines that never intersect. Algebraically, when you try to solve a system of equations that does not have a solution, you end up with the false statement. So something like 7 does not equal 8. Something like that is what would happen at the end of all of your algebraic steps. And the last type of outcome is the infinite solution system, and sometimes it's referred to as dependent. Graphically, when you graph a system of equations that has a set of infinite solutions, you're actually graphing the same line, multiples of the same line. So when you graph, you would just simply end up with one line. Algebraically, when you're trying to solve a system of equations with infinite solutions, you end up with the identity. You end up with that true statement at the end, ultimately leading you to 0 equaling 0. So those are the three types of outcomes. Let's look at the three methods we're going to learn. So there are three methods for solving systems of equations in two variables. So we're going to have x, we're going to have y. The first method that's always taught is the graphing method. And graphing is nice. We can use it on our graphing calculators. It's best to use when you have exact integer solutions, I guess. It's not always accurate. If if the solution would be 1/2 and 3/4, that might be difficult to identify on a graph, especially by hand. But I can show you how to do this in the graphing calculator, but by hand, this is not always the most efficient way to go, but it does visually represent what's happening. Substitution is a very important skill in math. Substitution is also a method for solving a system of equations in two variables. And then the third method that's taught is the elimination method. So we're going to go through all three methods rather quickly. We'll go through graphing quickly, substitution quickly, and probably spend most of our time on the elimination method. And then we'll bring in some word problems to show you the power of now having two variables in a word problem setting and how nice that can be. So let's go back and start with the graphing method, a one solution. And I've given you an example here on the cover sheet. So if I were to graph both of these lines, starting at 3 with a slope of 1, slope of positive 1, I'll just do dots. So this is my first equation. And then I'll graph the second equation in green. And let's see, this is going to start at 0. So my slope is up 1 and over 2, up 1 and over 2, or down 1 and over 2. Graph enough points for this evening when you do the homework so that you can see what's going on. And I will highlight in blue the point where the two lines intersected. So the solution to this system would be the point -2, +1. Because when I graph the pair of lines, this is the point where they intersect in the plane. And let's look at the graphing method for the next. So just analyzing this, you can see that they both share the same slope. They have different y-intercepts. So if I graph, I'll do the first one in blue, and I'll do the second one in red. Just so you have complete notes and a visual of each outcome type. My slope is +1. I have different y-intercepts. So the second equation will start down here at -2 with a slope of +1. So you can see the constant rate of change for each line is the same. The lines will never intersect. They're parallel lines, and this system would have no solution, no intersection point. And let me move over the screen and we'll do the last example together. So here's the infinite solution system, and you can see that the second line is actually just a multiple of the first. The second equation is a multiple of the first. If I were to take the first equation and multiply it by 2, I would end up with the second equation. So to graph this, you would just simply end up with one line, starting at a y-intercept of +3, and my slope is +1. And even if I were to graph the multiple, I would just be graphing on top of the line that I've already created. So that's a visual graphing example of each outcome. And let me show you what I would like for you to do for class so that we can move through this unit rather quickly and get to the more important pieces of the unit. The first thing that I would like for you to do is simply graph each pair of lines given, and I'm pretty confident that you all can get through that without any instruction on the video. And the graphs for these, I've provided the graphs for you right beside. So graph each system in the grid provided for that problem. Look for your solution set. Just make sure that you're okay with graphing lines. And I would like to take time on the video to talk about the substitution method. So that's going to be the Pizzazz 163. Substitution is best to use. To go back to the cover sheet, when is it best to use? Substitution is best to use when you have a coefficient of +1. When you have a coefficient of +1 on one of the variables. That's when substitution becomes really efficient and easy to use, okay? So when you have a coefficient of +1 on one of the variables, substitution is a nice method to use. So let's go back and look at a few of the problems on the Pizzazz 163 for the purpose of learning. So here in the first system, I can see that the y right here has a coefficient of +1. So what I'm going to do with this particular system, I'm going to take the first equation, and I'll color code this. I'm going to take the first equation and I'm going to substitute the y in the second equation with the value that appears in the first equation. So I have x plus, and I will make the y 2x, and I'll do it in blue so you can see what's happening, equaling 12. So this enables me to solve this system for an x value. So x is 4. And then to find the y partner, I can go back to either original equation that I'm given, and I can let x take on the value of 4. I always choose the easiest equation to work with, so I'm going to go with this. Y equals 2x, y equals 2 times 4, y equals 8. So the solution to this system of equations is the ordered pair 4, 8. Let's look at a problem like number 7. In number 7, I don't have a variable that's isolated, but x has a coefficient of +1. So it's easy for me to take this second equation and solve it for x. So x would equal 7 minus 2y. And then I would take this to the first equation, and I'll color code this again, and I'll start with -2, and in place of the x in the -2x, I will write 7 minus 2y. And then I carry on with the equation. Clear the ink. And now I'm going to solve this equation for a y value. So that gives me -14 plus 4y plus 3y equaling +14. So that means I have 7y is equaling 28. Therefore, y is 4, so I know that y is 4. And then to find the x partner, I go back to either original equation, and I'll just go with x plus 2y equals 7. And you can choose either one. So I'm only using this just to find the x value. If I let y become 4, then I have x plus 8 equals 7. Therefore, x is -1. So the solution for The set of equations in number 7 is the ordered pair. X is -1, y is +4. Let's do one more on the video. And let's do one like number 8. Let's do one like number 8. Problem like number 8. All right. So here I don't have a coefficient of +1, but the first equation, I could solve this easily for +y. So to do that, I'm just going to subtract 6x from both sides. And then if I divide each term by +1, then I've now turned this equation into that. And then I can take this to the second equation, and in place of y, I would have 2x plus 2, and in place of the y, I'm going to slip in 4 plus 6x. And then I would set that equal to 15 and carry on from there. And I think that I will let you all take it from here on the video.